I'm Ian Somerville, and I'm going to continue my series of videos on critical national infrastructure by talking here about infrastructure control. First of all, let me remind you about the different types of infrastructure which there are. There's physical infrastructure, digital infrastructure, and organisational infrastructure. Physical infrastructure is used to deliver services such as transport, energy and water treatment. It's a set of assets, power stations, railway lines, switching systems that are used to control, create and provide these particular services. The digital infrastructure is essentially comparable things for our digital services. It's the networks, it's the computers and data centres that we use to deliver the digital services to the nation. And the organisational infrastructure are the organisations which we need to have a functioning society. Government, emergency services, medical services and financial services. I'm mostly going to be talking today about the control of the physical infrastructure. It's now the case that all aspects of our physical infrastructure have associated computer-based control systems. And these computer-based control systems are used to monitor the state of that infrastructure, display information about that state, and to change the state of that infrastructure by issuing commands to individual infrastructure elements. There's a control centre, a control room, where a group of people 24 hours a day monitor the infrastructure. They look at what's going on, they detect, they spot faults or faults are reported to them, they take actions to repair these faults and they adjust the load on that infrastructure so that it can continue to deliver the essential services. If we look at the individual elements of the physical infrastructure, it's generally the case that each of these individual elements has got a small control system associated with it, and this is called a PLC, or Programmable Logic Controller. PLCs are standalone units which incorporate a microprocessor and which are explicitly designed to control hardware or mechanical equipment. PLCs have sensors associated with them which they can use to discover the state of the equipment, and they can send control signals to actuators, things which can change the equipment state, so they can open or close a motorized valve in a pipeline, say. This picture is an example of how PLCs might be organised within a pipeline to monitor the flow of liquid in that pipeline. You can see there are two valves, each with an associated PLC, and they measure the flow rate using the sensors which are before and after each valve. We have one before and after each valve because then we can tell if a valve is operational. With both valves, if the sensors are reporting different values, this suggests that there could be a breach in the pipeline so that liquid is leaking. So it's possible for the PLCs to close each of the valves and so isolate that section of the pipeline. The PLCs are connected to a central SCADA system, which is the system in the control room, and that's something which I'll be covering in another video. PLCs are small, simple computers, but they're not programmed using a conventional programming language like C or Java. Rather, they're programmed using a very special purpose language which takes into account the characteristics of the equipment that is being controlled, and that's called ladder logic. Ladder logic is not a language that most software engineers will be familiar with. Rather, it's something learned by the engineers who are developing the equipment that is used within the infrastructure. The other thing about PLCs is that they're designed to operate in hostile environments. Unlike a standard PC, which is designed only to operate in a very limited set of environmental conditions, PLCs may have to operate in areas where it's very hot, where it's damp, or where there's lots of vibration. So they're delivered in hardened cases, and these cases allow them to stand up to the difficult environment conditions and to deliver service continually over long periods of time. This is a picture of a group of PLCs. In this case, they are associated with the elements in a manufacturing plant, and each of these grey boxes is a single PLC. Sometimes we don't need to control an element, but simply we want to sense the state of part of our national infrastructure. And in this case, we use devices called remote terminal units, or RTUs. RTUs are very like a PLC, but they're rather simpler. Their only function is to collect data from sensors, to organize this in some way perhaps, and then to send it to the central control system. PLCs can be designed to act autonomously so that they have no connection with any other system, but more often they are connected to a central control system, and this is called a SCADA system. SCADA, standing for Supervisory Control and Data Acquisition System. SCADA systems are used to monitor, coordinate, and issue instructions to individual controllers within the infrastructure. I'm going to be talking about these in more detail in my next video. You can download the slides that accompany this video from my SlideShare account.